begin. We'll start off with a round of introductions. My name is Daniel Glasser. I'm the VP of Client Operations here at Neurala, and I am joined today by 4 of Neurala's AI specialists. We have Abhishek Gaur, Dr. Jeremy Werbs, Dr. Santiago Oliveira, and Dr. Matt Lucy. And we are going to be speaking over the next hour with how they have deployed game-changing AI across enterprises through their vast AI expertise. And as you may know, one of the most important parts of AI is data. And if you are interested in a solution to help you create high-quality training data for your own AI needs, please check out Neurala Brain Builder. You can take a look at neurala.com/solutions/brain and apply to join our Brain Builder program. During the course of the webinar, please feel free to tweet at us. You can use the hashtag #AskAnAIExpert or Demystifying AI, and we are at Neurala. So to get started, I think we'll begin with some of the questions that we've gotten in advance, and we'll begin at a pretty high level because we know that the attendees to this webinar are coming from a variety of different businesses and have a number of different interests in AI generally. So let's start with the notion of what kind of businesses should be thinking about AI and how should they begin the process of doing so? Abhishek, let's start with you.
I think the first thing, since you already mentioned that data is so important to creating good AI, companies that have a lot of data should look at the potential of using AI for a potential AI solution. And apart from that, you should try to figure out if your data has some sort of trend, or if it's a task which is similar to recognition, or if at any point is there any decision getting made. So in case of that, I think the businesses that have data that has some decision point in it, they can start looking into AI as a potential solution.
Yeah, we see a lot of businesses in the inspection market who want to go over a lot of maybe 20 hours of video, kind of boil it down to potentially 20 minutes. If you have something like that, AI is probably a good solution right now.
However, I think that in general, being AI is such a trendy and high technology feature in your business, if any business has anything on the technical side and there is a chance to be more competitive and be on the market, you can be at different stages. There's companies that are ready to go for start training something, or there are companies that are just starting to consider, hey, what if I have this camera and I can start thinking of doing something? There are different stages, and you can start. I'm ready to hire a company to get my product, or maybe I'm ready to start seeing what the whole business or what I have to do to get into that too. Adopt at different stages, not just if you have everything ready, not necessarily to have everything ready. Just.
Mm-hmm. So with that in mind, for companies that are starting to think about an AI strategy, what should they be considering? What are the factors that they should be starting with? Jeremy?
Yeah, that's a great question. So from last question, I would say everyone should be looking at AI. And then getting into what Abhishek said, if you're trying to determine what it is that you need to, can we incorporate AI into our solution pipeline, you're going to be looking for decision points, and you're going to be looking for things to see, is there a point where we currently have a human having to come in, make a decision? Can we trade data to automate that? So as Matt said, you're looking at the inspection market. That could look like, since 2010, drones have become very popular. So we're collecting tons of drone video for our cell tower, our power line, our oil rig, our oil pipeline. Can we take what is currently an analyst having to look at that video, and can we transform that data into something that is ingestible by AI to automate that process, automate that decision point? And if we can find these decision points that can be automated, then you're really at a good point to be finding value from AI today. Maybe that's the clearest way to put it.
That's great. And when you're starting to think about that AI strategy, what are the main steps of what that strategy should look like?
Yeah, also a great question. So we've worked with a lot of clients, and they come to us from different points. You hear people coming from the developer side, people coming from the management side. So I would usually split those two. So if you're on the management side, you've heard of this AI thing, you're like, is this for me? Is this something I need to be looking into? What I would be doing is, first, forget the AI. Just look at your customer needs. They could be internal or external. Look at your solution pipelines that you have, the value prop that you're getting, and then go through and determine those decision points that could be automated. Once you've done that, you want to see, okay, what data? So when I'm looking at this decision point, I need to consider what is the input and output of this point. And am I going to be able to collect the data that is going to be able to train the AI? So we're looking for input-output pairs into this decision point. I'm going to need to collect some thousands of these examples, and then we're going to use that to train the AI.
In addition to that, you definitely need to consult with AI experts and see if your problem is actually solvable. We do get the request from people to do things that are currently out of scope or out, you can't actually solve at this point. Things like detecting things from context that an expert could tell, like something is missing, something should be there but is missing. If you have something like that, we probably can't do that with AI. You should look elsewhere. But if you have something that you can detect from the appearance of the object itself, then definitely AI is a good thing.
So I heard a couple really important points there, and I want to make sure that we get a chance to cover all of them. So Jeremy, you talked about data, and I know there are a number of questions that we've gotten that we will be talking about data, quantity, quality, how to get it, how to tag it. And then Matt, you were also just talking about what's possible in the realm of AI. So, let's focus on that for a minute, and let's really think about, the types of problems AI is good at solving and the types of things that the technologists just can't do yet. Santiago, did you want to add something to that?
Sure. Well, the way I like to think of this is AI is supposed to be inspired on the brain. On the idea is a very simple representation, or our way to very simple do things that the brain can do. So one good rule of thumb to approach to think if it can be done is your brain. We all have brains, so we all can do certain things, and what we're trying to do is to put that into a computer, but we are very, very early stage and it can do very few things. So if you think your brain can do this, can the computer do it, then what we can do is very basic of what our brain can do. So for example, in vision, if you want to see, okay, I have my device and it has a camera, can we use AI to recognize these elephants in the jungle? Well, if you look at the images and you can see that you can recognize them, there's a good chance that AI can do it. If your brain, if you cannot see them, or if you see that it requires a lot of cognitive skill, like some inference or some previous knowledge, then that's something that most likely AI cannot do yet.
Yeah, I've heard the rule of thumb that if you could solve this thing in 1 second or less, then it might be good for AI. But if you need more time to think about it, maybe not.
Another good rule of thumb I've heard is if you take a team of 5 people and they were to all look at an image or a video and reach the same conclusion about what's in it, then AI can predictably repeat that result because you have some consistency in how the objects in the image are being interpreted. If there's a lot of ambiguity, I've seen use cases where people are trying to count, for example, wildlife in very camouflaged areas. And oftentimes people have a hard time distinguishing the objects of interest within a photo or a video. And I imagine that's the type of use case where AI is also going to struggle due to the difficulty in perceiving the things you're looking for.
Unless you have like infrared camera.
Right, no, of course. Obviously, there are different types of sensors and ways that you can overcome those types of challenges as well. So in terms of timing, when you're making a plan, thinking about an AI strategy, how long should businesses expect this process to take? Abhishek, you want to tackle that one?
Sure. I mean, it varies a lot depending on the problem you are trying to solve, and also if it's something that has already been solved or already has a solution that has been published by some research lab or some company, then there's a good chance you can, if your only task is to replace the data set and just train an existing neural network on a new task, that can take anywhere from 3 weeks to 12 weeks, depending on if you have the data available, the time will take to tag that data, and then training time on top of that. But if this task is completely new, and this is something for which the data is very available in scarcity, and then this is also a new research problem in AI itself, then it can go on from anywhere from 6 months to 1 year, depending on how long you take to collect the data, and then how much research time would actually go into creating this algorithm, testing it for robustness, bias, fairness, and everything related to how a deployable AI should look like. So it varies a lot, but in general, the cases that we have seen in the office, it can take somewhere close to 3 to 5 months to create a good enough proof of concept.
Yeah, and just to add a little more context to that, I would say that we've done projects here at Neurala where proofs of concept can have be done in easily a month, maybe 6 weeks, depending on the use case, and then production deployments might take a few weeks beyond that. So I don't want to scare everyone who's listening thinking that all AI takes a year before you can actually get value from it, because there is a lot of variation depending on the use case, like you said, the data availability, and whether it's a solved problem or if you're really trying to do something new and novel with the technology that hasn't been done before.
Yeah, it's also a very iterative process. I mean, you can start out with a model which is good enough for your use case, and then as you collect more data and as you iterate over the process, your model keeps getting better, and that's how most of the businesses operate even now.
So before we get into the question of data, because that is a big one, I want to set the stage a little bit and talk about, within the realm of vision AI, there are a bunch of different types of AI. In Neurala, we focus on vision systems, we focus on deep neural networks, and even within that specialized area, there are different types of approaches. So I want to just sort of summarize what are some of those types of AI vision solutions, because as we get into data, I know that the data needs will differ based on those different solutions. Jeremy?
Yeah, that's a great question. So this is obviously talking about data types, model types. Where are you in this huge domain of AI? We could talk about this for an hour, but at least just to give some guidance to the discussion you're probably going to want to have when you're talking to an AI consultant. You want to first figure out what domain you're in. So in Neurala, we're largely in vision. So you want to be looking at what is your input-output relationship for vision. The input would be vision, so it'll be images or video, maybe 3D data if you have LiDAR data or point cloud data. And then you want to look at what the output is, and that can tell you what domain you're going to be in. So very simply, you'd say, okay, my input are images, and my output, I want to know, what is this image? Is this an urban environment? Is this a landscape environment? Is this a selfie, someone's taking a photo? If that's the case, then we would say you're in the image recognition environment. You'd be looking for image recognition models, collecting image recognition data, and that's kind of the pipeline you're in. If you're saying, no, I need to know more, I don't just want to know this is a landscape image, I want to know what is in the image and where those things are in the image. I want to count people and I want to be able to point to them. And you say, okay, now we're in the detection domain. We're going to be looking at detection AI models, collecting data that can be able to train those. Move on. You say, okay, that's great, but I need more. I want to know pixel level precision of where these objects are. Be in the segmentation domain. you'd be looking at associated things. And then you'd subdivide, say, okay, I know I'm in segmentation, but you can segment that even further, class agnostic, semantic segmentation instance. And you would want to be able to find where you are in that. And then that would determine, what kind of data you need to collect, how much data, what kind of models. Are you going to be able to take something off the shelf, or are you going to have to develop something new?
I would imagine that as you're moving through those different types of AI, recognition, detection, and then segmentation, you're increasing complexity as you go from what's in the picture, where is it in the picture, and then really pixel level detail. Is that right?
Yes, but it can be very tricky. So you might say, we're in the 3D space. And you say, okay, one thing you could have like a registered LiDAR image. So basically a depth map. And you're like, oh, that's not a lot of information. It's only one view. I would rather have a full 3D point cloud. You might think that. But in actuality, all that new information, it's actually very difficult to ingest a map like that. So even though you might think you're simplifying the problem, from a technical level, you've just really increased the difficulty that you have on yourself. So yes, there's a correlation. More complex makes it harder. But sometimes more complexity can be a benefit if it's of the right type.
I think where I was trying to go with that was the notion that, as listeners might be considering their own AI needs, a lot of times we have customers who come to us and they've done some research and they have an idea in their head of this is what I need. I need detection because I'm looking for this type of defect, for example, rust on a pipeline, and I need to know where it is. But in actuality, because of how their data workflow exists, a recognition solution that just says in this particular photo there is rust is actually good enough, because that gives them the information they need to tell their maintenance teams, go to this section of the pipeline and fix it.
I think that's a very good point. When you're talking, if you were to come to Neurala and talk for consulting, make sure that you actually name what your real problem is and not what you think the solution would be. People come and they say, oh, I want to know what my crop yield is. And they tell you, okay, so I've looked at it and we're going to need some segmentation networks that can do instance counting. We're like, no, you really just want to know, is there a bunch of apples in this image? And we're going to fly a drone, we're going to take 10 images and we're just going to collect. And that's good enough for your use case as you stated it. So yeah.
Sometimes the problem can be solved more simply than one might think. We're going to move on and talk about data. I do want to remind people that there is a Q&A function within the webinar, so please feel free to submit questions. We already have a few coming in, and we will be sure to address those as we have time to do so. So probably the most frequent question we've gotten for this webinar, and that we get in general from our customers, is how much data do I need to train a model to be successful in using AI? And I know that's a very fraught question. So who wants to tackle it? Santiago, you want to take this one?
Yeah, I can start. Yeah, data is definitely very important, but as you say, it's really, really tricky because there's a tendency to think that the more the better, and actually the more data you have, the better you can train. But it is not always true. It has to be very good. It's better if you have good data. So you can have lots of data, but if they are not representative of the problem that you try to tackle, or if they are just biased towards, if you are not careful at what your data represents in your problem, then it doesn't matter if you have tons of data. It's better if you have less data, but that data represents your actual problem in different environments, in different conditions, different points of view. So rule of thumb in general is, I've heard, per every class you want to recognize or detect, you can get 1,000 images at least. So you can get a model started that doesn't overfit, that doesn't just memorize your classes. And that's probably a good starting point, but as Abhishek said, it reiterates. If you want to, for maybe your prototype and see how it works, and if it can work, then maybe that's good enough. As you want to go ahead, then you're going to realize that maybe you're going to need to get more data and better data, and then tag it consistently and all sort of things. Yeah.
Yeah. Sometimes what you'll find is that people will deploy a proof of concept and then realize it handles most of the situations that they want, but it doesn't handle something that they find is important. So then the only thing you can do is collect more data that deals with this edge case that you didn't think of beforehand. So you have to keep that sort of thing in mind. You might not just be able to collect it all in one shot. You might have to go and add to the data set.
Sure, absolutely. I mean, when you're thinking about AI, you talked about this idea of an edge case. You've trained a system, you think it's good, you deploy it, and only once it's in the field do you realize, oh, here's something we hadn't considered. What can customers do, I guess, when they're sort of thinking about their problem? What are the types of variation of, scene and object that they should be considering, when they're thinking about how to collect and assemble a good data set?
Well, they need to make sure it's as close to the eventual production environment as possible. So the AI model development phase depends on a testing set, which you set some metric up to evaluate and measure your performance. And that's how the model is built. So it gets better and better on the test set, and then you can say, okay, this is good.
So for example, close to production, you want to make sure that you're using sort of the same type of images, if it's RGB versus if it's infrared. You want the same type of camera, wide angle versus zoom lens, same type of weather and lighting conditions that you would expect to see in the real world.
Yeah. If you collect all your data with in the first try in daylight and situations, and then it's supposed to work at night, well, it's probably not going to work.
Exactly. Santiago, you mentioned an important word, which is bias. And data bias is something you hear a lot about. A lot of the big companies that work in the AI space are really making efforts to reduce data bias. And bias in general is a very heavy word. So Jeremy, what does data bias mean from an AI perspective?
Good question. So I guess most people are accustomed to bias in the public realm. You think racism, sexism. So that comes through too. But in the AI sense, it's even more general. And so it's, you can think the AI that you're training is playing a game to get the most questions right. And so if you say, here's 1,000 images of dog, and here's one image of cat, now I want you to guess, are these images dog or cat? It's going to learn really quickly. It can call everything a dog and get 99.9% right. And so when you're building your data set, when you're training your system, you need to make sure that your data is balanced and that your network isn't inherently learning that there's a trick it can play to win this game by biasing to one way or the other. And so usually at this point in time, fixing that issue is a data issue. There are a few model techniques that if your data isn't quite balanced or as we would like it to be, we can fix it a little bit, but the majority of the solution to this will be done in the data state.
So for example, if you're training a system to detect people, you want to make sure that you have a diverse representative set of people in the data set.
Yeah, so you think of, if you're doing face detection, Apple gets in trouble for only having European faces in its data set. Well, that's obviously going to have bias because it's not going to be well represented to your user base. And so you need to make sure that you don't have those types of data problems, data imbalances.
And so far, we've really just been talking about sourcing data, and we haven't even gotten to the point of annotating data. So Abhishek, how should people be annotating their data?
You should start with using Brain Builder for sure. And once you have that set up, the first thing that you should make sure is that you're tagging your data in a way which is the closest representation of what you actually want your system to do. So if you're trying to create a system that does segmentation, you want to make sure that you create your ground truth or the data that your model learns from in the most accurate way possible. So you shouldn't be mixing any pixels. You shouldn't be tagging. You shouldn't be lazy while tagging your data. Another thing that we encounter a lot and people should be careful of is that you should not have partially tagged images. So if you have two classes that you're trying to represent and there are multiple instances of that classes in an image, you should make sure that you're tagging all of them and not skipping one or two, because when the model learns, it learns to predict these classes. And it will predict that class regardless of whether you tag it or not, and that will hinder in its training process. So you would only have a partially good trained model. So yeah, these are the few things that you should be careful about when tagging or annotating your data.
That's great. I got a question from the audience. It was, how does Neurala address data privacy? Now, I know that within the Brain Builder tool that we have for annotating data, the data that each individual user uploads, they're the ones who have access to that data. It's transmitted securely, it's stored, it's not available to other users. But I think there's probably a broader issue, which is that as you're building data sets, privacy, public information versus private information, it's a very hot topic these days. So I don't know if you guys have any additional thoughts in general for our audience members, if they're going out trying to collect data, how should they be thinking about privacy?
How should they be thinking about it, or how should we be thinking?
How should they be thinking about it?
Well, they don't collect data that you're not allowed to collect. What?
There you go. I mean, no, that is, I think, important. It's, when we work with our customers, many of them come with data that's very specific to their problem, data that they've collected of infrastructure or things like that. So I think, obviously data ownership is an important issue. And then, at Neurala, we have worked on, projects that have had various, restrictions and confidentiality requirements. So obviously just the way any data like that is handled is of the utmost importance in making sure that it's not accessible or shared beyond where it's allowed. We've talked about validation testing as part of the training process and measuring the performance. For example, 99% dogs, 1% cats. What is a realistic performance threshold for people who are thinking about AI? How good can it get? And does that change depending on the use case, depending on the application?
Yeah, in the realm of solvable problems, it can get better than humans, but not perfect.
Better than humans, but not perfect. Would you like, how about some examples?
Well, self-driving cars detecting other vehicles on the road, I think it can get to the point where it can do a better job than you could in terms of locating all the vehicles. However, it might miss something. It won't be 100% perfect, and just like people sometimes miss something and cause an accident, AI could also cause an accident. But I think it will be better.
Yeah. Also, to answer your question about what your expectation should be, that would also vary from use case to use case. So if you are working in some medical use case and you're trying to detect if this person is at a risk of cardiac arrest, you do not want too many false positives. So in that case, accuracy sort of should be highest possible. Whereas in other use cases where you're just trying to create a portrait selfie by segmenting a human from a camera, if it misses some strands of your hair, it's probably not very critical, although it might offend some people. But in that case, your accuracy is not that, even if it's 80% to 90% accurate, that's acceptable enough. So it's very use case dependent.
Absolutely. Selfies are lower on the priority scale than medical diagnosis.
Yes.
One thing that I like to add is that an AI solution is not necessarily the final solution for a problem. It's typically a part of a solution. It's just something that a company gets us to do a detection or some job, but they have something else. For example, we can train here an AI brain to recognize cars and people. And then we can measure our accuracy of some 90-something% or some IOU. And the way we do it is we have thousands of images of different vehicles, different colors, night, day, raining, this and that. But that accuracy doesn't necessarily represent the accuracy of when you have the camera and you have the same vehicle in front of you on the highway. And this detection system is a part of a bigger system that uses those detections to be a part of it and do something else. So yes, that is useful to say, hey, it does what it's supposed to do and it does it this well. But then you should also take that as this is going to be a part of my system, and then whatever deficiencies or whatever usefulness it has is what I'm going to take for my system, and I'm going to make it a part of it.
And I should add that, no AI system is going to be perfect. At the same time, no human is going to be perfect as well. I mean, I think there have been studies showing that humans, reviewing data, looking for objects in images, depending on what they're doing, can achieve 97%, 98% accuracy. Humans get tired, they miss things. AI might be able to match that performance. But at the same time, there's another way to think about this, which is that AI doesn't have to be perfect if it is part of the workflow and not replacing an existing workflow. For example, we worked with a customer that was looking for, an object in images, and they're processing millions of images a day. The AI we trained was able to successfully filter out the 30% or 40% of those images where it's 99.999% confident those objects of interest don't occur. And then humans can continue to review the remaining amount. And what that means is that it's a much smaller workload for the humans because AI has successfully and with high precision filtered out the images where there is no object of interest. So I think it's important to consider the ways AI can be integrated into a workflow, into a solution. You don't have to achieve 99.9% accuracy for it to be useful and for it to provide value. So when someone is thinking about AI, they've collected data, they've hired us, or they have people within their company who are using that data to train a system, how much trial and error is there in that training process?
Sure, yeah, that's a great question. I think you should expect quite a bit of iterative processes in developing your AI solution. So figuring out how much data that you're going to need for your particular problem is a very high dimensional one. If it's similar to things that we've done before, we'll be able to supplement with pre-training data. If not, you'll be having to collect more data. So I think just in general, have a mindset that this is going to be iterative, and the iterations may even extend beyond deployment to your user base. And if you can continue to collect data after you've deployed, you can continue to improve, and it can continue to get better and better and reach whatever performance level you need. But a heavy dose of iteration should probably be expected.
Yeah, and in terms of R&D that goes into creating these architectures, your trial and error can go from anywhere from 2 to 3 attempts to 200 to 300 attempts in creating a system that that does what it's supposed to do and does it well. So in terms of creating architectures, if you know that this is a problem that this architecture was created for, and the only thing is needed that's needed is training, that might not require too much of a trial and error, and you might have to only switch, turn a few knobs of the neural network in order to train it well. But if it's something that that is sort of new, and I mentioned it earlier as well, that if it's something that you're trying to come up with a new solution for, there will be, your trial and error can go for a really long time, and you shouldn't be surprised if it doesn't reach the end goal.
And for businesses that are really trying to think about how to be successful in their AI strategy, what can they do to help guide that process to increase the likelihood of success? Because ultimately, investment in AI can be pretty expensive. And I know that a lot of people don't want to embark on that journey if they aren't confident that there's going to be something of value at the end.
You mean besides work with Neurala?
Yes, besides work with Neurala, of course.
I think you should start small. So when you know what your problem is, do not try to come up with a solution that you want to put in the hands of millions of users straight away. Try and start small, create a minimum viable product, and set very realistic expectations for that AI, which you know are acceptable enough, and you can take you can sort of face the consequences of that margin of error that you're leaving. And once you have that, and once you have a feedback from your user base, that is probably when you should start looking into expanding your data, making better models, and investing more time and money into training these systems at scale.
So it sounds like just as the models are trained iteratively, the AI strategy can also be iterative.
Exactly.
Start with, goal number one, the minimum viable goal. Invest what's necessary to get there, and then once you're successful there and start seeing some value, then you can stretch a little bit further because you have a better understanding of what's necessary.
Exactly.
Any additions to that train of thought?
I think that was a perfect point. You definitely want to start as small as possible with the smallest possible proof of concept. I think another big thing to keep in mind is to have a realistic expectation in mind, which is just combining, what we talked about before. In general, the simpler the problem, the higher level of performance the AI is going to be able to reach. We're talking about scene recognition, healthcare. Today, AIs can basically do superhuman performance on, is there a tumor in this image? Whereas if you want to do something more complex, you're not going to reach the 99.999%. So if you have something where you have a team looking at millions of images a day, and you have a very difficult problem, maybe you're looking to remove 20% and that's acceptable for you. Or if you are trying to remove the last two analysts you have and you need that 99.99, maybe your problem needs to be very simple that the AI is going to be able to handle it. So go through and evaluate what your problem is and come up with a realistic expectation of what the AI is going to be able to do, and then go to that minimum viable proof of concept as quickly as possible.
That's great. We've got a few questions coming in from the audience. Feel free to submit them if you have them. One question, how can Neurala's solution, how can Brain Builder work in non-vision systems like natural language processing? And the answer is actually it doesn't. We are focused exclusively on vision-based AI, but I know there are a number of other companies out in the world focused on natural language processing, unstructured text analysis, and I'm sure that they would be happy to hear from you wherever you might be.
It could be fun to work on if we had an interest, a pilot project or something. But that's not our expertise.
And this is why the R&D team does not handle business strategy. So another question that came in, and this is a good one for everyone to take a stab at. Where do you see AI going in the next 10 to 20 years?
I have 3 pretty safe predictions.
Oh,
But this might be a tricky question from our CEO also.
Yeah. But I'm pretty sure self-driving cars, you'll be seeing, like how you could go back 10 years ago. How many cell phones did you see? Like iPhones. That's going to be how self-driving cars are in the next, I think, 10 years. On your commute, you'll be seeing way more of them. Or cars in some self-driving mode with maybe a driver still paying attention. Second, I think in games, reinforcement learning is going to be controlling most of the AI in video games, as you've seen from like AlphaGo, and of course now solving chess as well. The third thing is probably recognizing people is going to become a kind of troublesome, I think. Keeping track and recognizing people, that will be something that is maybe people won't like. And I think some people will be working on like adversarial techniques to try to screw up the AI so that it can't recognize them and keep track of them. I think that could be kind of fun, but maybe not. We'll see.
So self-driving cars, really smart video games, and invasive privacy people tracking.
Yes.
Got it. Fun future. Santiago, what do you think?
No, I think of it in a different way. Like, if you look into the past, AI or neural networks has a history of coming like in batches. Like it was a time like in the 80s, maybe 90s, in which neural networks, or maybe before, had like a peak of interest and then it came down. Nobody cared. Now after, I don't know, 2010 or something, there was some sort of maybe breakthrough. And now it's up and still early stages of adoption at production industrial levels. And that make you think, maybe this is another, we should expect come down at some point. But there are so many people working on it, and technology is coming so fast. I think that it's more likely that at some point, not just everybody's going to be exploring the same area, but some kind of interesting breakthrough will come, and we will get into some other area of knowledge or some other techniques, and not only these areas or these specific applications that Matt was talking about, but it's going to be over the place, I think, all over.
Jeremy, what are your thoughts?
Very good points. I think if you look at what happened, why are we in an AI explosion right now? What happened in 2012? Basically, these AI algorithms that have been around for a long time got to a certain threshold that could compete with humans. And so for a certain class of problems, you could start to actually replace humans with these AI systems, and you can automate these decision points. And I think currently we're in this realm where the key point of making that happen is a lot of data. So I think over the next 5 to 10 years, you're going to be looking at a lot of work to reduce that part specifically. So all of the companies that we talked to, especially 3-4 years ago, it was a big shock when it was like, oh, we need to get data. How are we going to do that? And I think going forward, people will be developing techniques at the AI level, not at the data level, that will enable you to work on very few images, like what Neurala does with our LDNN technology, and advance that to the point where a whole new realm of applications will open up that people can take advantage of AI to put those in situations where you can't collect data, or you need to do it on the fly, you need to do it on the edge. And we're really just at the beginning of that, I guess. It'll be exciting, but I think it'll be transformative, the new opportunities that'll open up in the next 5 to 10 years.
Thank you, Jeremy. And Abhishek, the last one on this question. Where's AI going over the next couple of decades?
I think in its current state, AI is mostly deployed in cloud and in big data centers. So the biggest transition that I definitely see happening is that AI would, the amount of AI running on edge devices or small devices will go up. So your mobile phones, your televisions, and your speakers, as we can see. Apart from that, a lot, like Jeremy mentioned, a lot of focus on lifelong learning. And I feel there would be some sort of big breakthrough in unsupervised learning, just because there's so much data that is not tagged. And there's so much research going on in that domain that I feel like unsupervised learning is one of the major breakthroughs that's just waiting to happen at some point.
All right.
I like it. Yeah.
There have been a handful of questions submitted that are really specific to the type of work Neurala does. I honestly don't want this to turn into just a big pitch session where we talk about how awesome we are, but I'll tackle those real quick. We do focus on vision systems. They can be traditional cameras, infrared, a number of different types of sensors as input, video, still. And then our solutions can be deployed across a number of different types of hardware platforms, whether it's on a server, at the edge, on a mobile device, deployed on a drone, running a lower power GPU. So that's just a quick overview as to what Neurala's capabilities are. I would suggest if you are interested in learning more about us, please feel free to check out our website or reach out to us through the contact form on there. And we are, of course, always happy to talk about ourselves and our capabilities at length. I'll put out one last call. If anyone else has any other questions they would like us to address in the time we have remaining on this webinar. And I guess just, my last question then, oh, here we got one. How well are AI algorithms doing at predicting human intention? So this is not an uncommon thing that we get from potential customers. They're not just looking to find a person in a video, but they're trying to figure out, for example, what is that person's intentions? Are they acting in a threatening manner, for example? So what's the state of the art? What's technology capable of accomplishing in that regard right now?
So this is a tricky one because there are already systems which are really good at predicting few of the human emotions by looking at their face. Now the problem with that is a human can easily fake that. So there's no good way to tell if someone is smiling and like if their intention is totally different. So understanding intention or understanding context is something that AI is not that good at yet. But at the same time, there are systems which can there are multimodal systems wherein you take into account the vision, the words that the person speaks, the way they are doing the actions, the way someone, there's a lot of research on how actions translate into emotions. Yeah, I think it will be really hard for AI to predict human intentions, but I think that is one space that we will see growing as well in the next phase of AI. Yeah.
I mean, I should add that, depending on the problem that someone's trying to solve, there may be technology approaches that are not, specifically intention predictions that can be useful. So for example, there are AI technologies to determine trajectory.
Right.
And where, an object or even a person is likely to proceed based on, position and, past velocity. And that could be used to determine, for example, likelihood of perimeter breach around a secure facility or something of that nature.
You're thinking of their intention of going from point A to point B, not their emotional intention.
Well, right. I mean, intention can have a lot of different.
Exactly.
So perhaps one way to put it is, are you in a cooperative environment or competitive environment? If you're looking at someone in a store, they're looking at an item, and you want to know, do they intend to buy this item? They're not really trying to fool the camera. And so AI can really help, make some analytics for this. Whereas if you have someone specifically lying to the system, having a human as an adversary is going to be a very difficult game for an AI to play when it comes to human intention.
That's a good point.
Yeah. And just like predicting actions, like what can the future action be? Their action recognition is a very researched field, and there's a lot of research in video in temporal methods as well, when you take into account how the behavior has been in the past. So there are systems that can predict some sort of future or what the next frame in the video can be related, like all the research that has been going into generative adversarial networks. But yeah, if a human decides to fool an AI, I think it will be really hard to do that.
For now.
For now, yeah.
Well, I think that about sums up most of the questions we've gotten. If we haven't reached your question, feel free to follow up with us outside of the webinar. Again, I want to thank our panelists today, Abhishek Gaur, Dr. Jeremy Werbs, Dr. Santiago Oliveira, and Dr. Matt Lucci for their insight, their experience today. I want to thank all of our attendees. Again, just as a reminder, this will be distributed via email to all of you after the webinar concludes. If you do have any questions, want to talk to us specifically about Brain Builder or our other AI technologies, feel free to reach out, info@neurala.com, or contact through our website, www.neurala.com. Thank you all, and have a good rest of your day.
Thank you.